All right, here we go into a very cool little video on what is known as logarithmic differentiation. So this is a really neat other way of deriving a function that, even though there's no logs in it right now, we'll have logs in it shortly. We use logarithmic differentiation either when you're asked to use logarithmic differentiation, right? Or when you have a really funky derivative that has like chain rule, as this does, and quotient rule, or chain rule, quotient rule, and product rule. If we were to take the ln of both sides, watch what happens. All of a sudden, we can use log properties to break up that right-hand side, and that's the whole goal here. And you're allowed to take the natural log of both sides. So watch what that allows us to do. We can now rewrite, before we take a derivative, the right-hand side. This would be the ln of all of that. So it's the ln of x squared minus 2 to the 1/2. Right, that's what that would be, because it's a square root, minus, because you're dividing, ln of a over b is ln of x cubed plus 1. And if you're forgetting those properties, check out the first video of chapter 5. Okay, so now from here, we're actually going to take a derivative with respect to x. And when we do that, some cool stuff happens. The derivative of this would be 1 over stuff d stuff. That'd be dy dx, right? Because the derivative of y with respect to x is equal to, now, you know what? I could have brought that 1/2 out front too. I'm just realizing that. Sweet. That's going to make life even easier here. So before I take the derivative of that right-hand side, I stop and I say, look at that. Nice. I could bring the 1/2 out front. Now we've expanded the most, and now let's take a derivative of the right-hand side. Okay, so I'll take a derivative of the right-hand side. It's going to be 1/2 times 1 over stuff. Ooh. D stuff, which is times 2x, minus 1 over stuff, 1 over x cubed plus 1, times the derivative of that stuff, 3x squared. You might be like, dude, Groden, this was not better. It's easier to do than holding the quotient rule and the chain rule in your head, in my opinion. All right, we'll clean up the right-hand side. 1 over y dy dx is equal to, the 1/2 and the 2 cancel, but you still have an x, over x squared minus 2, minus 3x squared times 1 is 3x squared, all over x cubed plus 1. Now, I want to solve for dy dx. That's what I want. So to do that, I'm going to multiply both sides by y. Right? If I multiply both sides by y, I will effectively get dy dx alone. So I get dy dx is equal to all of this stuff on the right-hand side. That's x over x squared minus 2. Be careful that you copy correctly. I've done a couple of takes now because I did not copy correctly. Times the y value. Well, most teachers and professors are going to want you to write that in terms of x. That would be this. You replace all of y with that y. So that would be times, I'll put it in parentheses, the square root of x squared minus 2 all over x cubed plus 1. And that is your answer. So logarithmic differentiation, again, like I said in the beginning, great for if you have a funky derivative. I don't typically use it a lot, to be honest, but I do use it when I'm asked to use it, or if I've got one heck of a quotient with a product and a chain rule. Then the logarithm process is great. All right, I'll see you next time. Peace.